Hello class, so I've got a few easy kind of concepts I just wanted to tie up, some loose ends before we start reviewing for our test on derivatives. And so that is the trig and special derivatives, and I also want to talk about approximating derivatives from tables. So first, here you see is a list of derivatives of trig functions and a couple special derivatives. So let's start with the trig functions. We're all familiar with sine, cosine, and tangent. Well, sine and cosine have a special relationship when it comes to derivatives, and that is the derivative of sine is cosine. And then the derivative of cosine is negative sine. The derivative of negative sine is negative cosine, and then the derivative of negative cosine is sine again. So it loops back around forever and ever. If you just keep taking derivative after derivative, you will get one of those four. So this is an important chart to remember. Also, the derivative of tangent is secant squared of x. We'll talk more about trig functions as we go through the course, but that's some good trig to know as far as derivatives. Over here on the right, you see I have two special cases here. One is the derivative of e to the x, and that's actually our favorite function in calc because the derivative of e to the x is itself e to the x. So I could take e to the x and I can keep keep taking derivatives. I could take the first derivative, second derivative, third derivative, fourth derivative, and they're all going to be e to the x. So that's always nice to work with. Then lastly, we have the derivative of the natural log of x. That's the ln of x. And the derivative of the natural log of x is just 1 over x. So keep those in mind. Write those down somewhere. Yeah. All right. So let's talk about approximating derivatives from tables. So let's recall that the derivative function gives the slope of a function at any point. So therefore, if you think about it, slope and derivative are essentially the same thing in the sense that if I'm asking for the slope of something, you can take the derivative to find it. Or if I'm asking for the derivative, you can just look at the slope of it, and that will give you the derivative value right there. So nothing like going in straight to an example. So here it says, find the value of the derivative at the following x values. And I should have said at. I don't know what I write half the time. At the following x values. So here we're given a table, and it's a function f of x. We're given the x values, and we're given the corresponding f of x values, or y values. And I want to know what is the derivative at those points. Well, we're not given an actual function that we can work with where we could take the derivative and then, evaluate, plug in the value and look at the slope at that point. So instead we're just going to look at the slope of this. And it's not going to be the exact slope, it's going to be the average slope or the average rate of change. So this is what you want to do. If we are given, or if we're asked, what is the slope at x equals 1? We want to look at the points to the left of it and to the right of it. And remember what the slope is. It's the change in y over the change in x. If you're unfamiliar with this little triangle, it's delta. It just represents it represents the change of. So really, remember when we're thinking about this, it's if you like formulas, it's y2 minus y1 over x2 minus x1, where x1, y1 is a point, and x2, y2 is a point. So basically all we want to do is look at the points around the given given point, and we can approximate the slope, or approximate the derivative value. So if I'm looking at x equals 1, I want to look at this point 2, 3, and I want to look at the point 0, 7. and I'm going to plug it right into my slope formula to find the slope. So let's see, the change in y, so 3 minus 7 over 2 minus 0. So let's see here. 3 minus 7 is negative 4. 2 minus 0 is 2. Negative 4 over 2 is negative 2. So if I had the function of this f of x, if I had the equation of f of x, and I took the derivative at 1 and plugged in 1 into the derivative, I should get somewhere near 2, or sorry, somewhere near negative 2. Okay? Let's take a look at the next one. So at x equals 3. So now we're looking at this x equals 3. So I want to look at the point to the right of it and the point to the left of it. So I'm just going to take the change in my y, so 7 minus 3 over 4 minus 2. Well, that's going to be 4 over 2, and that is 2. So again, the derivative at that point should be somewhere around 2, because that is the approximated slope. Looking at the next one, 4, it's going to, this works the same way. So here, we're going to look at this point and this point. So 12 minus 4 divided by 5 minus 3. 12 minus 4 is 8 over 2, and that gives us 4. So the derivative at x equals 4 should be 4. Let's take a look at x equals 5. So this is an interesting circumstance, and that is we are only given the points from 0 to 5. We don't know anything to the right of it. We don't know anything to the left of it, and so therefore we can't assume anything. And so because it's on the edge, we don't have a point to the right of it to find the average slope. So in this case, at x equals 5, there's not enough information. We can't just assume things. Likewise, if I asked what is the average or what is the derivative at x equals 0, again, we're not given at the point negative 1, so we can't assume anything. We don't have a point to the left of it. So that's all I have for y'all today. Again, just some easy concepts, loose ends I want to tie up before we start studying for the test. So that's it. Let me know if you have questions. Have a good day. Bye.